Hey guys, welcome aboard to the next video. So far we have been looking into chapter 1, and in the last class we looked all that there is related to relations. So now, with no further ado, let's begin with functions. The first thing I want us to do is define what a function is. Now, if you don't know what relations are, you will need to check out the previous videos first to understand this better. Now, the definition. Let's say I have two sets. Let those two sets be A and B. Now, I can say that there is a function mapping, so this arrow means mapping, from A to B if it satisfies a condition. And the condition for this relation, in essence, to be considered a function is that every element of A has a unique element in B. This is the most important definition you need to learn when you're talking about functions. Now, you might be wondering what that means. Let's understand this better with an example. So let's say I have a set A and I also have a set B. And let me define set A as 1, 2, 3 and set B as A, B, C. And I'm saying that I want a function mapping from set A to set B. Now, for this to be considered a function, remember every element of A has a unique element in B, which means I can have a situation where 1 goes over here, 2 comes like this, let's say 3 doesn't have anything. In this scenario, this element of A has a unique element in B. Check. This element of A has a unique element in B. Check. But this element does not have any element in B. Look, there's nothing going there, no arrow. In this case, this is not a function. It doesn't satisfy the condition. But let's say I do this. I say 3 is going to C. A unique element in A going to a unique element over here in B. This scenario is definitely a function, and this is correct. Now, there are certain terminologies that you have to understand when you are studying this chapter. See, everything over here, it's the input. It's what you're giving into the function. So if I have f of x is equal to y, this would be your input and this is your output. A, in this case, is kind of like this x. It's your input. So over here, this input can also be called a pre-image. It's called a pre-image. And this B over here can be called an image. It's actually pretty simple to remember. Just think of it this way, all right? When I have something like pre, this is a prefix. Whenever I have pre, it means coming before. So this comes before your image. That's what this is, all right? And I also have a few more words that I can use to talk about set A and set B in this example, which are domain and codomain. All the elements in your set A will be called your domain. So in this case, your domain will consist of 1, 2, and 3. Similarly, all the elements, every single element in set B. So over here in this scenario, I only have 3 elements. But let's say, for the sake of an example, I add an element, okay? Let's say I have D. Now you might be wondering, hold on a second, sis. If you add D over here, won't this stop being a function? Now here's where you have to notice, every element of A has to have a unique element in B. It doesn't say anything about the elements in B, right? So technically speaking, every element in A has a unique element in B. This is still a function. It's all right, okay? So in this case, your codomain would consist of A, B, C, and D. Now you might be wondering, okay, domain is all of this and codomain is all of this, but what do I do if I only want to denote A, B, and C? Because those are my outputs. If I give in 1, I will get A. If I give in 2, I get B. 3 gives me C. I don't need any D over there. I don't need my codomain. Well, in that scenario, you have a word called range. So your range is sort of like your output. This A, this B, this C, all 3 of these would consist of your range. I hope that makes sense. If it doesn't, just pull back the video and watch it one more time and it'll make more sense to you. It might take a couple of attempts to really get it in, okay? Now, in functions, before we jump too into it, another thing you have to understand is this. Whenever you have a function, your range will always be a subset of your codomain, and that can be understood better when you just look at this example, okay? And this symbol over here basically means that this range, let's say I have a big circle, okay? And let's say this big circle is your codomain. Let me put brown over there so you remember. I can have a range which consists of this entire circle. It can equal my codomain, or it could only be a part of my codomain. So this means that it's a subset, or it could be equal to your codomain. In both of these scenarios, your range will be a subset of your codomain, or your range will equal your codomain. This is a condition that never fails in functions, so always keep it in mind when you're solving future problems. Now that we have discussed all of this, I just want to show you one more example, or actually a couple of examples related to functions so that you understand this even better, okay? So suppose I have A and B, and this is only for you to kind of understand how I can call it a function and how I cannot call it a function. So again, I have A and B. Again, I have my function. Now let's say I have 1, 2, 3, and I have A, B, C, okay? Now watch carefully. What I'm gonna say is, I'm gonna say, when I give in an input of 1, I'm gonna get B. When I give in an input of 2, I'm gonna get B. And when I give in an input of 3, it's still gonna give me B. Now, watch carefully. In this case, all 3 of these are giving me a single answer, B. It's not going to give me A, it's not going to give me C. So in this case, your range is only B. Your codomain would be A, B, and C, and your domain is 1, 2, 3. Now pause for a second and tell me, is this a function? Again, remember, when it comes down to functions, we only focus on the elements in A. So 1 is having a unique element B. That's a check. 2 has only one element B, unique element, check. 3, also a check, meaning this is a function. This example is correct. If you're kind of confused, then let me show you another example to understand this better, okay? So keep this example in your mind, and let me show you a slightly different version of this. So in this slightly different version, again, let me draw my beautiful diagram. Actually, it's not that beautiful, kind of shabby, but deal with it, okay? It's the maths that's important. So again, I have function, and it's mapping from A and B. Now watch, again I'm gonna have A, I'm gonna have B, I'm gonna have C, and over here, let's say I have 1, 2, 3, okay? It doesn't really matter what is over here. So in this example, my A consists of A, B, C, and B consists of 1, 2, 3. Doesn't matter. I just switched it up so you understand that it doesn't matter. Now, let's say, again, A is getting 1, all right? And let's say B is getting 2, but let's say that B is also getting 3, and let me just add a number over here. So C is getting 4. Now, you might think this is similar to the previous example, but it's not so similar. In our previous example, each one of these only got B. They each got only one thing, but over here, B is getting two things. It's getting two, but it's also getting three. Going back to your definition of every element of A getting a unique element in B, well, this is not unique because I can also get 3. This isn't unique, meaning in this scenario, you cannot consider this a function. I hope this makes sense to you, and with that, we have understood functions a lot better. In the next video, we'll look into the different examples related to functions. Thank you.